Hi, this is Dudley Toolwright, and today I think we have an interesting project. It should be quick, but it's interesting. I may need to make a mounting plate for the side of my Acra Mill where I think they intended the hose for the coolant pump to come out. There is a bored hole about 1.2 inches in diameter with a M8 by 1.25 threaded hole for mounting. The interesting part comes in that I intend to have about a 1/4 inch protruding section on the mounting plate that will stick in the approximately 1.2 inch diameter hole that will prevent it from rotating while the through hole with the threaded screw will hold the part in place. I intend to turn this in a offset mode on the lathe, which is the interesting part. I've never done it before, so I think it should be challenging. I know it can be done. Also, I will need to drill a through hole for the mounting screw, the M8 by 1.25 screw, and 4 additional holes that are going to be 1/4-20 that are intended for holding the plate that will eventually attach an arm attached to. So at this point, I have faced the piece of aluminum and turned a section of the outer part to clean it up. The outside dimensions are really not critical. The only thing that's important is the offset protruding part relative to the threaded M8 by 1.25 metric screw. So at this point it's centered in the 4-jaw chuck, and now I need to move the aluminum slug offset in one direction, and having never done this before and concerned a little bit about the stability, I think one of the things that's going to be important is to make sure that it can't come out, because it's going to be a fairly large chunk of metal with an offset position from the center of rotation, so it's going to want to throw itself out of the chuck. Now, I think the jaws are probably good enough to hold it, but I am going to center drill and use the live center anyways, just to make sure that this can't happen. I'm playing around with position because, again, the absolute location is not really important. I could have made this square and made this relatively easy, bored a hole through a square metal plate, welded in an aluminum section that was the right diameter, and could have moved from there. But this sounded a lot more interesting, and it'll end up one piece and pretty. I'm still looking at it, using the live center to help decide the position, so figure out how much my offset is. A bit clumsy, as you can tell, not the greatest dexterity, but yeah, still adjusting, trying to get the right amount of offset. So I'm going to check with a ruler to make sure it's at least larger than the diameter of the part I'm trying to turn, with a little bit of neck, so that it won't fall in the hole, even though it's going to be a much bigger piece than the hole itself. And I tighten the other jaws, even though they're going to score the outside of this piece of aluminum pretty nicely, but I make sure it's really good and tight. Now for the additional safety of a center drilled hole for the live center to fit into. Slow and easy, I think, is going to be the name of this game. Yeah, I think that should lock it in pretty nicely. Okay. So next I make my first big screw up where I pull the tool back, but not far enough for clearance. It seems like it is, but it's not. Novice move. Whoa. Okay. First screw up already. You were too close, even though you didn't think you were. Check to make sure that you have clearance. Poorly done. Poorly done. Could have been worse though. Could have been steel. Probably would have broken the tool. Maybe done more damage. Wow. All right. Yeah, check out the interrupted cut. Pretty impressive. So it looks like here that as I start to cut that there's a bit of bouncing, but in reality there isn't very much at all. The camera is mounted on the live center on the tailstock, and so it bounces a little bit more, combined with a really wide angle lens with things up close, kind of amplifies motion a bit. Talk about interrupted cuts. So I'm going 180 RPMs. I didn't think I'd go much more than that, just with this really terrible offset weight. Talk about out of balance. What I'm going to do is, I'm going to keep cutting until the cut is not interrupted anymore. And then once I've got an uninterrupted section, then I'll cut that part normally at a higher speed so I can get a better finish. Although the finish doesn't look terrible. I gotta say again, the Acra lathe, it performs really well. I'm always surprised. Keep waiting for the other shoe to drop. Maybe that's longevity, which obviously I won't be able to tell for a long time, but so far it survives my mistakes, it survives general abuse. I'm quite impressed. Okay, doesn't sound like it's too strenuous. I think my next attempt to see if I can speed it up a little bit is going to be taking about 4 thousandths of revolution. I don't think that should be too bad. We'll give it a shot. We'll wait and see. The worst part is on the outside when it takes a big chunk out of just a tiny section of a fast-moving, out-of-round item. Part. Yeah, here you can see there's a fair amount of noise conduction through the mount of the camera, which, like I said, was sitting on the tailstock. So I just noticed that my being left-handed, my arm to lubricate things comes over the moving parts of the lathe. I wonder if the world had been more oriented towards left-handed people, lathes would have been built backwards with the headstock on the right and the tailstock on the left. That way my hand wouldn't have to cross over the moving part to put lube on. Here it is going at twice the feed rate. I think it's always wise to start small and inch up, see what things can handle. So you might notice what sounds like a lot of gear noise and a lot of whining. That's almost all conduction noise. In the room itself, as far as ambient noise, there's not very much at all. Kind of interesting. I might try a slightly bigger bite, try 30,000s or 40,000s, see how it goes. There's a tiny amount of vibration in the thing, in the waves, but tiny. It's handling it really well. Actually, it's just in the plus side. After this pass, I'm going to take a measurement on diameter again on the mill and see what the hole is. I've got it as 1.91. It's not even metric or inches. It's a pretty rough hole, so I'm going to go take another measurement and then cut down the center to final dimensions. Not a critical dimension, so 1.620. So 175. Okay, I think we are good. I made it a little bit smaller because the hole's not critical. It's not at all round. You know, it's a casting with a, I think it's a hole that's been cast. So at this point I realize I'm going to need a datum point on the other side of the part to find the center of this aluminum protrusion so that I can find the center of the through hole for the metric screw that'll mount the part to the Acra mill. So what I decided to do is to drill a very small hole through the part, through the center of this aluminum protrusion so that I can find it on the other side. I didn't think I'd achieve this much so early in the morning. That was a number 49 drill bit. Got to chamfer the edge a little bit. I think we should do that. Before we take this out of here, because when we're done, it's not coming back. I wonder if I can fit. This will fit in there. Am I gonna hit? Am I gonna hit? Am I gonna hit? Tight. Kind of pretty. I know, I got a thing for metal. It's one of the reasons I like machining so much. Make really beautiful things out of metal. I got lucky. A-bomb, watch out. So I find that oiling up my file before I cut aluminum especially, I can prevent it from loading up so badly. Alright. Now we just got to figure out how to part this sucker. That's a big piece of meat there. I don't know if you can use these with that much stick out. Holy cow. So I suspect at this juncture some old timers are looking at this and going, holy shit, that is not going to work. Yeah, I don't know how else I'm going to part it. I could use a hacksaw or something, but I don't have a bandsaw, and I'd like to cut it off, and I guess we'll give this a shot and see if it works. Maybe we'll go a little slower. So in hindsight, I think it was still moving too fast for the cutoff blade with that much stick out. I probably should have slowed it down even more. I've zoomed past all the squealing. It turns out if the old timer said, what the hell are you doing, they would have been right, because I end up breaking my cutoff blade. It's a high cobalt, pretty hard cutoff blade, and makes it brittle, and it really didn't appreciate being stuck out almost 2 inches. Oh. And that's why you don't do it. Too much stick out of the cutoff tool, and ba-boom. Done. That's a shame. So at this point I just give up and hacksaw off the end of the part and reface it in the lathe after I've hacksawed it off. Live and learn. So the next part is to find the center and the center line. And the center. So the next part, I have to drill 4 holes for quarter 20 or quarter 28. I haven't decided yet. And one, these are tapped holes, and this is one body drill, an S drill for a M38 by 1.7, 1.25, an M8 by 1.25. I might just be the world's fastest machinist. When I set this up, I was a little concerned about only clamping in 2 points, and I thought maybe I'd be gentle, but you can see right here it moves a little, and should have thought of a better way to fixture this. I may be fast, but I think I'm lacking in hand-eye coordination. Just a little bit. Okay, a little bit. No, seriously, really. Okay, last one. Still have to make an arm and bracket for camera and tools and whatnot, but plate's done. Thanks for watching. I'll see you next time.